Hello everyone and welcome to another Bitesize Bioinformatics. I'm Steven Wingett and today I am going to be introducing to you the software VirtualBox. Just to make you aware, this Bitesize Bioinformatics is going to be a little different because I'm currently working from home and unfortunately my internet connection is very slow. I'm actually having to connect via tethering my computer to my phone. For that reason, I have pre-recorded the Bitesize Bioinformatics and it's being played to you as live. At the end, however, I will be trying to answer any of your questions you may have about the talk. For those of you sitting in on the Zoom call, if you want to ask any questions or bring anything to my attention, you can do this via the Zoom menu bar at the bottom of the screen. All you need to do is move the mouse pointer to make the bar visible, and then click on either the chat to send me a message, or if you want to get my attention, just click the raise hand button. Okay, let's start with the talk. So, what exactly is a virtual machine, and why do people find that they need them? Well, you're probably all familiar with Microsoft Windows. That is the common operating system that you find on most machines. It's very easy to use. It has a graphical user interface with nice icons that you can click to open up software that you're interested in. And while that's great and it's widely available, it does come at a cost. It's a commercial product and you have to spend money to acquire it. And for that reason, among others, many software developers over the years have developed rival operating systems which are freely available. The most well-known of these is Linux, which I will talk about in more detail later in the talk. Because it's freely available and the software is open source, meaning that people can go in, look at what the software is doing and contribute to it, Linux has become a de facto standard in the bioinformatics community. Indeed, in many areas of academia, Linux is widely used as well. Because of this, because bioinformatics software developers are building their software on Linux, we now have a situation where much of the software that's available is only compatible with Linux, and if you have a Windows machine, you simply can't run the software. Needless to say, this is a problem for you if you only have a Windows machine. Of course, you could find a way around this. You could, for example, uninstall Windows from your machine and then install Linux, and then you can carry on running bioinformatics software. But obviously, for most situations, this is simply not practicable, and people don't want to destroy a Windows setup that they've already established, possibly over many years. Another possibility would be that you could pay to use an online Linux box, which you could interact with and then use as a Linux machine. But for most people, what you really want to do is to be able to use Linux on your regular machine without it interfering with your Windows setup. A way to achieve this is to use something called a virtual machine, and that name is in many ways self-explanatory. It's essentially a virtual computer that you can run on your host computer as a simple program. So the idea would be that you may have some sort of icon on your desktop, you go in, you double click it, and then it opens up a whole Linux computer which you can interact with as though you had installed Linux on that machine itself. Needless to say, this is much more convenient than the previous solutions that I've mentioned. It's also a very safe environment. The virtual machine is sandboxed away from the main machine, which means it's a safe environment to do things. So you can install software inside the virtual machine, you can download data and not have to worry that there are any viruses on there that could interfere with your host machine. It can be considered for all intents and purposes as a separate machine and a separate entity. So virtual machines are a very nice way to be able to experiment with different operating systems and different software on your regular machine in a convenient, safe environment. So let's suppose now that you have decided that you would like to run a virtual machine on your system. How would you go about doing this? Well, there are a variety of ways to do this, but in our experience, the best tool that we found is something called VirtualBox. VirtualBox is a bit of software that's freely available from the website www.virtualbox.org. And once you navigate to that site, you should be able to see clearly how to download the software. And I'll just briefly discuss this in a little bit more detail later on. Now, VirtualBox is compatible with Windows, Linux, and Macintosh operating systems. So far, I have assumed that you will have a Windows system and that you'll be wanting to try out a Linux operating system as the virtual machine within the Windows host machine. However, all the possible combinations are possible. So with VirtualBox, for example, you might have a Linux machine and you want to try and run a Macintosh operating system within that. So that's one of the strengths of VirtualBox, is that it's pretty much platform independent. You can use it on most of the common operating systems, and then you can try out most of the common operating systems as the virtual machine. However, as we carry on with the talk, I'm just going to assume that you've got a Windows or maybe a Mac machine and you want to try out a VirtualBox to try out bioinformatics tools. One of the key strengths of VirtualBox is that it is completely free, so you won't be spending money to get hold of it. And it's also open source, which means if you're interested in this sort of thing, you can look at the code and you're free to change it as you wish. And it's distributed under the GNU General Public License version 2. VirtualBox is made by the software company Oracle. So you may not have heard of Oracle. It's not as famous as software companies such as Microsoft, but it is one of the world's largest software companies. Perhaps you're familiar with it for producing the software language Java, for example, and it also produces well-known database management systems. I only mention this because the fact that VirtualBox is produced by Oracle is, while it's not necessarily a guarantee that the software is great, it does sort of lend you some confidence that it's good by the fact if you look at the other successful products in Oracle's portfolio. Also, the fact that it's produced by a large company rather than a single sole developer just adds an air of confidence that they're not going to discontinue it overnight, or the development on this software is going to cease. So I think with that, if you spend a bit of time investing in learning VirtualBox, it's unlikely that that time is going to be wasted. Okay, so let's suppose that I do want to go ahead now and install VirtualBox. How would I go ahead and do this? Well, as I mentioned briefly before, the first thing you need to do is navigate to the website and download it from there. So the website is this virtualbox.org, and if you go there, you'll see just a little bit of introduction about what VirtualBox is, and you should see a great big button like this where you can download the current version of VirtualBox. So if you just click that, you'll then go to this page here where you can download the software itself, and depending on the operating system that you have installed on your machine, just click on the relevant link. So if you've got a Windows operating system, you just click on Windows Host, click the link, and then it should start downloading the software. And that's what we can see here. We're downloading this Windows executable file. It's quite large, it's about 100 megabytes, so depending on your download speed, it might take a little bit of time. But that's how you download the software. So it is fairly to install. The installation procedure is the conventional installation procedure for, any regular bit of software that you would install on a PC or a Mac. So I don't want to go into too much detail in this talk about the mechanics of software installation. But if you're unfamiliar with this or you're having difficulty installing the software, I have put together a video already on our YouTube channel. This is the Vibram Bioinformatics channel, and here we have a whole list of uploads and videos that we've made previously on a whole range of topics, and one of them is the VirtualBox setup tutorial. So if you go and have a look at this, it will describe in more detail how to download, install the software and get it running. Okay, so we've now installed VirtualBox. The next thing we want to do is set up and create a virtual machine. So the first thing we need to do this is decide what type of virtual machine we're going to make. Namely, what sort of operating system is it going to run? Is it going to be Windows, Linux, Mac, or what have you? So for this demonstration, we are going to create a Linux virtual machine. I think that's the best one to demonstrate because we're primarily interested in running bioinformatics software. So if you've had any experience of installing operating systems in the past, you will be familiar with the idea that you have the operating system, historically now I guess, on a CD-ROM or DVD or even in a USB. And the idea is you would pass this to your computer, which doesn't have our operating system installed. It would then read the disk and it would start the installation process of the entire operating system. And the similar sort of thing takes place when you're installing an operating system on a virtual machine. Essentially, create your virtual machine, you open it up, and then sort of install a virtual disk. So a virtual disk in this case is something called an ISO file. It is a disk image. It stores the operating system as it would appear on an optical device like a CD. And when you pass that to your virtual machine, it will read that and it will begin the installation process. So the thing you need to do is get hold of this ISO file. So that's what we're going to demonstrate here. Let me just go back a second. Okay, so we're going to use Linux, and we're going to use install a type of Linux called Ubuntu, which is probably the most well-known version of Linux. So you can get hold of Ubuntu from the website ubuntu.com, and there are other versions of Linux, but if you just go to their home pages, wherever you go, there should be a very obvious download button. And if you just click on that, what you will see are the different options for downloading Ubuntu. And we want the desktop version of Ubuntu, and the latest version is here. With Ubuntu, often the latest version will have LTS after it, which means long-term support. This is a version of Ubuntu which is going to be maintained quite a while into the future. So that means you'll get updates and patches and that sort of thing. So with Ubuntu, I'd recommend getting the LTS version. And if you just click on that, you'll start downloading an ISO file. And you should be able to see it appearing here. Okay, so that will take, it's a very large file, so it will, depending on your internet speed, it will take a while to download. But once you've got it, you can then go ahead and install it into your virtual machine. Okay, so we've now downloaded our operating system of choice. The next thing we need to do is create our virtual machine. So if you open up VirtualBox, you'll see something like this. This is the sort of home page, as it were, of the software. You might not see these. These are virtual machines that I've already created. This will be empty on yours if you're starting from fresh. But if you click on each of these virtual machines, over here you'll see some information about them, the sort of specifications you get of a computer, giving you the memory usage and all that sort of thing. Okay, so what we now need to do is go ahead and build a virtual machine from scratch. So quite simply, if we click on the new icon here, and now we begin the process of setting up our virtual machine. So we want to give it a name, so I would pick a name that makes sense to us. So for this, I shall call it Ubuntu, and I shall call it Demo, because we're demonstrating what it is. There's also a place called the machine folder. So when you create your virtual machine, all the files associated with that machine will be saved here. So there'll be a default location. I'm going to stick with that for this now. If, however, you find that there is a more convenient place to store all these virtual machines, then definitely change this location to somewhere where you want to save them. This is particularly important because virtual machines by their nature tend to be very large, and if, for example, you have a disk partition and you have like a data partition and a smaller partition, you might want to make sure that the virtual machines are being saved in a place that has adequate storage, and you don't want to fill up your memory allocation of your machine just through creating lots of virtual machines. The next thing to do is let the VirtualBox know the type of operating system you're going to make. So if you click on this, you'll see a drop down, and there are different types of operating systems here, but we're making a Linux machine. And actually you can specify the version of Linux here. Not every version of Linux is available, so in which case you would just have to specify other Linux. But for us, we are interested in making an Ubuntu VirtualBox. So if we click on that, it will make an Ubuntu virtual machine. Also, you need to check the type of spec of your host machine as well. Most modern machines now are 64-bit, so that's almost certainly what you'll need. So I'm going to create an Ubuntu virtual machine, and that is the sort of initial setup process. So I click OK. Now I need to specify the amount of RAM. This is a little bit more of an art than a science. It will give you a recommended amount to start with. What I would bear in mind is that often for bioinformatics software, you're going to be using quite memory-intensive tools. So I would tend to pick quite a high memory specification that is, allowable within the terms of your computer. So I would have a little read around before you start. Check the memory spec of the machine you're using. Maybe look at the memory requirements of some of the tools you're going to use, and then use that to inform your decision about the amount of RAM you allocate. If you don't get it right the first time, it's not a disaster. If it seems to be running slowly or getting memory problems once you've created your virtual machine, just go back, start again, up your memory allocation, and then see if it works. But as I say, there is a little bit of trial and error here. So for these purposes, I am going to choose, say, let's go for around about 4 gigabytes of RAM. Okay, click continue. And now it will specify the hard drive size of the machine. For this, I'm going to create a new virtual hard disk. I'm not going to use an existing one, and I will click create. And now I'll be given a choice. And now I'll be given a choice of the type. So if I just use this VirtualBox disk image, click continue. So the defaults tend to be right here. So when I get to this step, I get asked a choice between whether I want a dynamically allocated hard disk file or a fixed size hard disk file. Now the fixed size file is a little bit faster, but unfortunately when you have created it, it automatically essentially fills up. So if you want 100 gigabytes of storage and you create it, you've already lost this from your host system. So what I recommend is the dynamically allocated. You specify this, it will start off small, and then it will expand as you add files to your virtual machine. One thing I should point out is once the data has been allocated to your virtual machine, even if you then delete the data from your virtual machine, the hard disk space taken won't shrink. So it's a sort of one-way process. However, it does allow you to start off quite small in terms of file size, so I would leave it checked as dynamically allocated. So this is where you can specify the amount of memory that is allocated to your virtual machine. As I said, the operating system is quite large and you might want to download some large files. So for example, if you were downloading FASTQ files for mapping, these can be several gigabytes in size. So it's worth having a large amount of storage memory if you think you need it. and I'm going to just specify something ample. What I think my purposes will be around about 50 gigabytes. And I'll click create. And then what you'll see is a new little icon has appeared here, and that's essentially our blank virtual box. Okay, so we've now created our virtual machine, and in a sense this is a bit like creating a virtual computer. We've made the machine, but there's no operating system sitting on it at the moment. So what we now need to do is install our operating system. So we'd previously download the ISO file, which is analogous in many ways to a CD, and essentially we want to put that into our virtual machine and then start it running and reading the disk and installing the software. So what we do is we click on our virtual machine, like so, then we click Settings, like that, and then we click Storage. And then from here, we want to select our optical drive. So if we click this, and then what we'll see is a list of options of ISO files that it's recognized before. If the one you see isn't there, you just click Add, and then navigate as you would do normally to the file in your file system on your computer. So my ISO file is here. I'll click Open, and I click Choose. So I'm going to choose this Ubuntu version as my operating system, and I now click OK. So what that now means is when we start the machine up, it will start reading this ISO file like it would read a CD if it were a real computer, or a DVD. If you don't do this and you double click on the virtual machine, you'll just see a message similar to no bootable media found. Okay, so let's turn on the machine. So I double click on that and you'll see something similar to this appear. There'll be a message about auto capture. So we have a system on the virtual machine where it can capture the mouse pointer. So if you imagine we've got the mouse pointer here outside the virtual machine, but then when we're inside this square, we're actually navigating the pointer around the screen of the virtual machine. So it's like we've got two screens on our one screen. When the pointer goes in here, it can be captured. And if you look at the bottom here, the bottom right, you'll see a command that will allow you to unselect a captured cursor. So what that means is if we move the cursor in here and we can't get it out again, if we do this left Mac command key, we will get the cursor out again. There'll be something similar if you've got a Windows machine. You'll see a similar message to retrieve the cursor, or if you're running it on another operating system, you may see another command there. But that's how you get the captured cursor out of the virtual machine if you need to. So I'll just close these little dialog messages, and what you can see is Ubuntu is now starting up, and this is now going to take you through the installation process that you would see, pretty much as you would see if you were trying to install Ubuntu again on a real computer. So what I want to do is I want to install Ubuntu. So we've got the language is English, and now if we just click install Ubuntu, and this will take you through the installation process. Now I'll spend just a little bit of time going through this just in case you're not familiar with it. So the first thing it wants to do is to check your keyboard layout. There's quite a nice feature. If we just, for now, we'll click English UK. There is quite a nice feature if you want to detect your keyboard. You can just click detect. It will then ask you a series of questions. Basically, it'll ask you to press certain keys on your keyboard or identify whether certain keys are present or not, and that way it can detect your keyboard automatically. But for this, we're just going to say it's an English UK keyboard. We click continue, and then we carry into. And basically, I would, unless you have any particular reason why not, I would stick to the default default installation options. So click continue once more. Now it will say erase disk and install Ubuntu. Now don't worry about this. When you do this using a VirtualBox, you're not going to delete the operating system of your host machine. You're only going to wipe the VirtualBox. So erasing the disk and install Ubuntu, yeah, let's do that. So we've got this closed sandbox environment of the virtual machine, which allows you to delete everything and then carry on. So we'll just click continue here, and the installation process will take place. Continue. Okay, so it's up to you what you want to call your machine. I'll just call it test VM for these purposes. I will make up a password. I'm just going to have a weak password for now because this purely is a demonstration purpose. If you click this, you'll log in automatically and you won't need the password. If you don't click this, then you will have to enter your password. The thing I've just noticed is we can't have underscores in here. So if I just delete that, everything should be okay. And we'll click continue. Remember, for real life purposes, use a nice, strong, secure password. And now we're going to do the installation process pretty much as you would see if you were installing the software on a real machine. This can take some time, so for the purposes of demonstration, I'm going to freeze the video here, and then I'm going to come back to you when all of this is completed. So when the installation completes, you'll see a message like this, and then if you click the button, you'll restart your machine. Once you have created a virtual machine, all you need to do to open it is to move the mouse over the virtual machine of interest and then double-click to open the machine. As an aside, one thing I should point out is sometimes when you start a virtual machine, the size of the screen that's displayed can be very small or just look wrong. The way around this is to change the screen resolution. So if you do that, if you type this, press this little button here in Ubuntu and type display, and then you select screen display, you can change the screen resolution here. Can be a little bit fiddly if the screen is small to start off with, but that's how you would do it. And then select a resolution that's appropriate for your monitor. Okay, so you've now installed Ubuntu, and basically you have an operating system. And this is where you can do all your necessary work in a similar way that you would to Windows. For a lot of bioinformatics applications, you would open a terminal, such as this. So this is the command line interface. You have root access to this, which means you have full admin rights, so you can install anything you want on the machine and uninstall it, and you have full control. So it's a very nice way to have a nice, safe environment that you can do anything with and install and remove software as you like. So yeah, it's the typical command line environment. Commands like ls, cd, whatever, all the Linux commands you can use here. If you're not familiar with these commands, Vibram Bioinformatics does give courses on using Linux and such environments such as this, so that would be a nice course to go on. But this is your basic Linux setup, and that's the terminal. What you can also see is it's not just a basic terminal environment that you may have seen for some versions of Linux. We have this nice graphical user interface, and here you can open the software as you require. So for example, here we have LibreOffice Writer, which is the Linux sort of equivalent of Microsoft Word, and you can open that to make documents and that sort of thing. So essentially now we've got a full operating system running in our virtual machine on our operating system. So we have a computer within a computer. So now we've successfully created a virtual machine and we're running it on a host machine. And that's all well and good, but it would be nice if we could allow the two to communicate with one another. For example, suppose we create a file on the virtual machine and we need to move it to the host machine. How exactly can we do that? How can we move things between the two systems which are essentially completely isolated from one another? Well, there are a number of ways to do it, but a good solution we found I'm now going to describe. The first thing you need to do is make sure you have a server install on your Linux box. So to do that, for Ubuntu, you would do the command sudo apt install, and then it's open SSH server. And you'll need to type in your sudo password. And click Y to continue. And for other Linux systems, you would either use the same or a similar command. If the apt install doesn't work, it may be a yum command you need to use. Okay, so now that seems to be installed, we just check it's working. So if we do sudo service SSH status, and we can see with the text in green that it is running, which is good. Okay. So now we just want to identify the host name. So if we do hostname I, and there we can see the IP address of the hostname. So we can now use this information and use the fact that we've installed this server to move files between the two systems. The first thing we just need to do before we can do that is configure the VirtualBox configure the virtual machine using the VirtualBox program. So what we do is if we go here and then we go to settings, and now if we do network, we go to advanced, and then we click port forwarding, and then we create a new rule like so. And just for speed purposes, I'm going to enter the information and then pause the video and then show you when it's done. So if you enter in these details, as I can show you here, and then you click OK, we should be all now ready to go to move files between our host and virtual machine. So now I've set this up, I need a bit of software to be able to move the files between the two machines. For this, to do this, I'm using a well-known bit of software called CyberDuck. So I've opened it up here. I'm going to create a new connection. I want to choose an SFTP connection, and the server will be the IP address that you saw previously, this 127.0.0.1. The username will be the username I created for the virtual machine. So you can see that here, it's test_VM. So I will enter that here. So this is the username we created when we did the installation. The password is the password I also entered when we performed the installation, and we want port 2200. And all being well, if I click connect, there'll be an unknown fingerprint for the first time, so if I click allow, and now we can see files on my virtual machine. So this is the file structure that we can see here. If I do ls, desktop download, documents downloads, desktop document downloads. So now if I want to transfer a file, all I need to do is drag and drop. So I'm going to move this test file, click allow, The file now should have transferred. We can see it here. And then if we go back to look at our virtual machine, and now if we type ls, we'll see the file is there. And likewise, we can move files from the virtual machine back to our host machine in this fashion. So we've finished with our virtual machine session. How do we shut it down? Well, we could simply close the program, but we don't really want to do this. If you click on the virtual machine, you have a choice of options. You can save the state of the machine, which will save the machine exactly as it's looking at the moment, if you will, and then when you reopen it, you'll open up it'll open up in the same state. You could essentially do a power off, and that's pretty much akin to pressing the power off button on the computer, which is not great, and that can cause problems the next time you try and open up the virtual machine. Or you could instruct the machine to close in an orderly fashion with the ACPI shutdown. The way I would recommend doing it is closing it as you would when you're actually closing a regular operating system. So I would click on the within the operating system, within the user interface, I would click on the control panel here, and then click the power off button, and then that should close down, and you're done. Just for a sense of completeness, I wanted to say a few notes on Linux. Many of you out there may not be familiar with this operating system, and it might seem quite new and daunting to you at the moment. So maybe unlike Windows, there is not one particular version of Linux that's being made by one sole manufacturer. Linux was started many decades ago, and it was based on an operating system called Unix, which was proprietary software. Linux was essentially the free version of that. And from that initial development of Linux, many people have gone on to develop their own particular flavours of Linux, as it's known. Each of these different flavours has its own particular strengths and weaknesses, and which ones you go on to use is really entirely up to you. I just wanted to mention a few of these so you become familiar with the key Linux distributions available at the moment. So I found this nice diagram on Wikipedia, and it shows you what is essentially the family tree of Linux. It works a little bit like a biological family tree, so you have like a root, which was a very early distribution of Linux called Debian, and then from that you see all the different flavours of Linux which were derived from this operating system, from the Debian version of Linux. And you can see this, and a particular notable branching point is Ubuntu. So Ubuntu is the version of Linux which I just demonstrated to you, and then from this lots of other different versions of Linux were derived, and you can see that there are actually very, very many different versions of Linux that have been built over the years. You don't by any means need to know hardly any of these, but I am just going to, as I mentioned, summarise the key ones just so you become aware of what's available in the field. So the first Linux distribution I want to discuss very briefly is Ubuntu. This is the actual version that we installed on our virtual machine. It's a very popular version of Linux. It's possibly the most widely used for the sort of home user. It's very easy to use, and it is a large community of people who use it and will support you if you have any difficulties or have any questions. As such, it makes a very good starting point for anybody new to Linux. Another commonly used Linux distribution is Linux Mint, which is actually based on Ubuntu. It's grown rapidly in terms of popularity in recent years, and like Ubuntu, it now has a large community of users and is very easy to use for the beginner. Personally, I probably find it slightly easier to use for a beginner than Ubuntu, but either Ubuntu or Linux Mint make very good starting points for the user new to Linux. So CentOS is a Linux distribution which is aimed for servers. It's based on a version of Linux called Red Hat, and it's what we actually use on the Bayram compute cluster. You can download it with the graphical desktop environment that you're used to in the previous versions of Linux already discussed, or you can download a minimal version of CentOS, which just has a command line environment. So I just wanted to talk briefly about another application of virtual machines. Virtual machines can be very useful in making it easier to disseminate software that you've made. So imagine that you've just produced a nice new software tool and you want to make it available for the community. That's all very well said and done in theory. You might be able to provide instructions on how to install it and run it and what have you. But in reality, there can be lots of conflicts, dependency issues when you produce a new bit of software. And then you have a situation where your software is out there in the community, but people really are struggling to get it running. And that can be a problem because you're trying to make something that people can use, and then people aren't using it because it's just hard to install. A way around that is to put together a virtual machine. So essentially you put together an operating system, you put together all the dependencies, get it working, install your software, and then you can bundle the virtual machine, and people can try the software themselves and use it for their analysis. Or at least, if they can't do that, they can see the software actually running on maybe a small data set, and then they can see and then they can look at the dependencies of the operating system they're using and try and troubleshoot what's different about the system that works on the virtual machine and on their own native system which is having problems. So it's a nice way to disseminate software. A similar sort of thing could be, for example, Singularity or Docker. People can bundle software that way, or you might go down the route of a virtual machine. An example of this that we actually put together at Bayram was for a software tool called Close Call, which looks at something called proximity RNA-seq data. So after we published the paper, we made the data sets available on the Open Science Framework webpage, and we made analyzed data sets there, and we also uploaded a virtual machine on which people could download and then run Close Call to see how it works. Incidentally, Open Science Framework is a nice website for uploading data files that you probably wouldn't necessarily deposit on the regular resources such as Geo. So in a similar fashion for what we've just discussed about using VirtualBox for distributing software, we found VirtualBox very useful for our training courses. So as you may be aware, Bayram Bioinformatics runs a series of courses on topics in bioinformatics and statistics. So people attend the courses from the UK or even outside the country, and they often will be performing the analysis on the course on their own machine. So as you could probably imagine, there could be quite an initial setup cost in terms of getting people up and running. So people might turn up with different versions of operating systems or indeed different operating systems, and they might have different versions of software installed, for example R, or different aligners installed. So to actually run the course to run the courses in a streamlined, efficient way, we need some sort of standardization. What we found works very well is if we ask the people who attend the course to install VirtualBox, we then make available a virtual machine which they can download and then run within VirtualBox on their own computers. And that way they have access to a standardized operating system. All the software is pre-installed and everybody has the same version of the software. And we can also make all the training materials available on the training box as well. So they can have the instruction manuals on there and all the test data sets that are required for the analysis. So there are lots of ways that VirtualBox can be useful. And it helps standardize protocols and procedures, and it allows people with different machines to perform the same task in the same way. So just to summarize, VirtualBox is a piece of software produced by Oracle which enables the user to build and run virtual machines. And a virtual machine is essentially like having a computer within your real computer. A key advantage of this, especially within the bioinformatics community and the life sciences communities, is that it allows users to be able to run Linux-only software on their Windows machine. A key advantage of VirtualBox is that it is free and it is open source software. The software can easily be downloaded from the website virtualbox.org. Another advantage of creating and running a virtual machine is that it allows you to try out different operating systems and setups without having to completely install software on a real computer. Furthermore, virtual machines allow you to standardize your analysis. You can set up all the dependencies and the operating systems that you need and all the available data sets. You can then produce the VirtualBox, send it to other people who can then try it out and perform the same analysis in exactly the same way that you did it. Not only does this help the standardization process, it also allows other users to troubleshoot any problems they may see when trying to set up the same pipelines that you've already established. Okay, so thank you for listening to my talk, and I hope that was useful. Hopefully, as long as my internet connection allows, I'll be around to take any questions or queries you might have. Thanks once again. Bye-bye.